Hi, welcome to the 10th video in the series of videos on simple machines. In this video we're going to talk about block and tackle pulleys. Now before we talk about block and tackle pulleys, just a quick recap on a single fixed pulley. All right, and this is your single fixed pulley, and you have a load of 100 Newton, and this load of 100 Newton, as it moves through, the distance of the load is 10 centimeters. Your distance of effort you get is exactly 10 centimeters. So here you have your velocity ratio is equal to 1, and your mechanical advantage also is equal to 1. So the effort that you're putting in is exactly 100 Newton, right? Now, a block and tackle system is a way to improve your mechanical advantage. So the reason why we call a block and tackle is this is your block, and this is your one of the blocks, and this is your other block. So these are two blocks, and these are your two blocks, and the thread that goes around these pulley system, and these threads here that goes around your pulley system, these are called your tackles. So that's where the name comes from, block and tackle pulleys. Now in this, so the first important thing is to be able to draw this block and tackle pulley. But before we do that, let's quickly analyze what would be how this pulley be different than a single pulley, right? So here my objective is to move 10 centimeters up, and as you move 10 centimeters up, both these ropes need to move up by 10 centimeters, which means that this your effort would need to move down by both these threads need to move up by 10 centimeters. That means your effort would have to move down by 20 centimeters. So straight away you know that your velocity ratio is equal to 2. In general, the number of ropes pulling up the load is equal to this load. The number of ropes pulling up would be equal to your velocity ratio, and your mechanical advantage would be equal to ideal mechanical advantage would be equal to 2, in which case your effort would be equal to your load divided by 2, and that's equal to 15 Newton, and that's your effort is 15 Newton. All right, so that's how the system works, and the reason why your 100 Newton is translated to 50 Newton is because you have two ropes which is balancing that 100 Newton. So you have 250 Newtons tension which is balancing this 100 Newton. So that's how the block and tackle system works. Now it's very important to know how to draw your block and tackle system. So if you ever get your even number of blocks, so this is your block and tackle with number of pulleys, number of pulley equal to 2. So in which case it's quite simple. So you create a pulley in the top, and you create a pulley in the bottom, and then you add this load. And it's very important that you start drawing this block and pulley system from your effort side, so that you know how to wind this rope, and finally where to attach this rope. Right, so this is one of the most critical things of drawing a block and tackle system. And finally, you have to be able to mark your load and tension and effort, etc. Right, and one more thing to note is your velocity ratio is number of threads which is pulling the load up, and it's also equal to the number of pulleys in a block and tackle system. It's also equal to the number of pulleys in a block and tackle system. Now, in this case, you have 3 pulleys. So straight away I know that my velocity ratio equal to 3 and my ideal mechanical advantage equal to 3, and hence my effort is going to be equal to load by 3, which is 33.33 Newton. So that means that when this height moves up by 10 centimeters, all these 3 ropes will have to move up by 10 centimeters. Thus, you have to move the effort arm by 30 centimeters, and that's why you get a velocity ratio of 3, right? Which is nothing but your distance moved by effort by distance moved by load, and in this case that's equal to 30 by 10, that's equal to 3. And your effort is 33.3. The reason why you get that 33.3 is because this tension, the 33.3 is balanced by this tension, and these tensions are equally distributing the entire load of 100 Newton, and that's why you get these tensions as 33.33, which is nothing but 100 by 3. I would like you to take a pause here and try to draw this block and tackle system by yours, or wait a minute, I will try to draw this one, so maybe the next one you can try to draw by yourself. So in this case your number of pulleys is 3, number of pulley equal to 3. So the way you draw is, whenever you get a 3 pulley system, put both the pulleys in the 2 pulleys in the top and 1 in the bottom. So you have to split it up exactly. You cannot split it up as half as previously. So you put the 2 pulleys in the top. The top one is big and the next one is small, and then the bottom one down. And once you do this, then you always start drawing from the effort side, so you know how to loop your pulley up. So the pulley, the rope goes, the tackle system goes, which is like that, and it loops around, and you see here it hooks up in the bottom, unlike in the previous one where it was hooking up in the top. And then you mark all your tension and your load. In this case, this is a block and tackle system with number of pulleys 4. So I would like you to take a pause and find out what your velocity ratio is. Find what is your this distance S is, and what is your mechanical advantage, and what is your tension in the rope, and what is your effort. And also I would like you to draw this block and pulley system. So why don't you pause the video here and try to do these things. So here you get a velocity ratio of 4 because the number of pulleys is 1, 2, 3, 4, or you can say number of threads pulling up is 4. Either ways it's fine, and hence your displacement of your effort arm would be 4 times the displacement of the load arm, so that's about 40 centimeters. And mechanical advantage is, ideal mechanical advantage is same as velocity ratio, and your tension is distributed by the 4 threads, so you get essentially 12.5 newtons. All these tensions are equally distributed, and this is how you draw this. Now in reality, block and tackle system, though you have seen that all the blocks are vertically like this, you will find these kind of blocks only in labs. Mostly your blocks are horizontal in nature. That means that you have this block and then you have this multiple pulleys here. So you have, just like this, just like what you see here in the crane. So you have multiple pulleys, and then these ropes are wound around these multiple pulleys, and that's how you have the block and tackle in real life. And next time you walk near a metro construction, you must observe the crane which is lifting, and you will find this block on this end, and also of course there is a block in the top, and that helps the motor, which is somewhere over here, which is pulling this, and the effort required. If you have 1 ton and then if you have about 16 threads here, then essentially the load over here, the effort you need to put is 1000 divided by 16, if there are about 16 threads which are pulling this up, right? So that's going to be your effort for 1,000 kilogram, lifting 1,000 kilogram mass. So next time you go near a metro construction, so please take a look at this block and tackle system. I hope you enjoy the series of these lectures of Simple Machine. Please share your likes and reviews and feedback, etc. Thank you so much.